Hey guys, it's Hazel and welcome back to another ACE Explains video. Today we're going to be going over how to calculate the average atomic weight of an isotope. So remember that an isotope, let me start with talking about average atomic weight. Average atomic weight is not an actual average. It's a weighted average that takes the average of all of the naturally occurring isotopes that belong to an element in the universe. So basically, like carbon or nitrogen or chlorine, they all have a number of naturally occurring isotopes, and the average atomic weight takes the sum and then the average of all of those naturally occurring isotopes. So when you're calculating an average atomic mass problem, you are quickly just doing like very basic math. You're gonna want your calculator to do some of these problems. So we're gonna try a couple of examples here together. So rubidium has two common isotopes, rubidium 85 and rubidium 87. If the abundance of rubidium 85 is 72.2% and the abundance of rubidium 87 is 27.8%, what is the average atomic mass of rubidium? Now, if you'll remember from my from my isotopes video, then you know how to interpret the symbols that you see in this question. And if you don't know, then look out for my isotopes video where I explain all of that. That should be in the link in the description. So we're told that it has two isotopes, so we're only going to be using the two isotopes that were presented to us in the problem. And they are rubidium 85 and 87. And we're given the percent abundance of rubidium 85 and the percent abundance of rubidium 87. So the way that you calculate atomic mass is you take the the mass of the isotope, and you multiply it by the percent abundance of that isotope in nature. So like I was saying before, all elements have a certain number of naturally occurring isotopes, whether it's like 3 or 4 or 2 or even like 10,000, but I don't think 10,000 actually. I don't think 10,000 at all. I think like the max is like 3 or 4. But each type of isotope has a percent abundance. So it's out of the whole amount of isotopes, how many of those isotopes are of one type or the other. So for example, rubidium has 2 isotopes, right? So out of all of the isotopes, 72.2% of them are rubidium 85. The other 27.8% are rubidium 87. And that makes up 100% of the known isotopes belonging to rubidium, if that makes sense. So we are going to multiply the isotope's mass and the percent abundance of that isotope. So what does that look like for this problem? So if we start with rubidium 85, the mass, the atomic mass, I think I should have written atomic mass up here. The atomic mass of rubidium is 85. And we're going to multiply that by the percent abundance of rubidium 85 in the universe. We're going to add that to the other isotope. So it will be 87, since that's the mass, times 27.8%. Now, we can't put the percent symbol into the calculator, so I'm going to rewrite this problem and change the percents to decimals. And you can do that on your piece of paper, or you can do that in your head on your calculator, whatever is easiest for you. Another way to do that is to solve the problem and then divide by 100 later. Everyone does it differently, but that's how I'm going to do it. And I'm going to quickly put this question into my calculator. If you're following along, I encourage you to do the same. Hold on. 87 times 0.278 and we get 85.56. So the average atomic mass, right, that's what they asked for, the average atomic mass of rubidium is 85.56. And I don't believe, correct me if I'm wrong, but I don't believe that there are any units that are ascribed to this value. I think the value is just 85.56 or 85.6, however they ask you to represent it. I'm gonna represent it to 2 decimal places since that's standard, but they may ask you for 3 decimal places, they may ask you for 1 decimal place. It's really up to them. Okay, let's try a second example. Uranium has 3 common isotopes, so that's 1 more than last time. We have U-234, U-235, and U-238. So those are our 3 isotopes. And by the way, isotopes can be written like this or like this. I don't know if you remember from my video on isotopes, but that's why I'm reading them. I'm reading them U-234, U-235, etc. So those are our 3 naturally occurring isotopes, right? And these are the percent abundances that are associated with each isotope. Right? So what we're gonna do, we're gonna find the average atomic mass. 234 times 0.001. Hold on. 0001. 235, 0.0071, and then 238 times 0.9928. And remember, this is just me converting the percents into decimal. Just want to make that clear. Okay. I just want to make sure I did this correctly. Yeah, okay. We're all good. Okay, 234 times 0.0001 plus 235 times 0.00071, 0071. Oh my gosh, you should be so careful, guys. Plus 238 times 0.9928. And the answer is, the average atomic mass is 237.98. Okay, let's try a last example to hit it home. Titanium has 5 common isotopes, right? And they gave us the isotopes, their masses, their atomic masses, and the percent abundances. So we just have to copy what we see here. 46 times 0.080 plus 47, that's that one right here, 47 times 0.078, that's the second isotope, plus 48 times 0.734, that's the third isotope, plus 49 times 0.055, that's the fifth isotope, plus 50 times 0.053. And that is the fifth isotope. I think I repeated the same number twice. Okay, put these all into the calculator, just like it's written. Make sure you enter carefully so that you don't mess up any of the decimals unintentionally. That way you don't mess up your hard work by a simple calculator error. And you get 47.92 as the average atomic mass. I would like to point out, and you may have noticed this pattern, you may not, that all of the average atomic masses are very close to the isotopes, to the atomic mass of the isotopes within the problem. So 47 is really close to 46, 47, 48, 49, 50. It seems to be around that number. Same thing if you look at the second question. We have 234, 235, and 238, and we got 237 as our answer. Again, right around there. And then if you look at the first example, we had 85 and 87, and then our answer was like 85.5. So when you're doing average atomic mass and you're trying to figure out if you did it correctly, if your answer is correct, your average atomic mass should be close to the naturally occurring isotopes that they gave you in the question. All right, thank you guys so much for watching this video. Let me know if you want any more chemistry videos. I'll obviously be doing some, but if you have any special requests, let me know in the comments below. As always, if you have a question, make sure to ask in the comments and someone from our team will answer them. And if you need more chemistry help, make sure to check out our Ace the Chemistry class playlist. That will be in the link below. All right, see you guys next time. Bye-bye.